Okay, welcome back. This is Chapter 24. This is the last of the video lectures for the entire course. So is that a hooray or is that a, oh no? Okay, here goes. So design patterns, multiple layouts, and fragments. So before we even get started, let's just talk a little bit about design patterns. There's this really cool book out here. If you're going to be a serious programmer, okay, you probably need to have this book in your library of programming books. It's actually pretty doggone, now it's kind of old, and some of the things they talk about are a bit esoteric, but it's a good muscle memory kind of book. It talks about, how do you set up one of these things and how do you do this? And so it's all about these design patterns. And so we're going to talk about one particular type of design pattern called the Model View Controller. Almost always it's abbreviated the MVC, Model View Controller, on page 578. So this model is really applicable to practically anything. It's not just Android. I use this model when I'm doing the C# class, or if I'm teaching the Java class, or I'm teaching the C++ class. Same thing. And so I'm using the same model every single time. And so what it does is it separates the program into separate layers. And layer is just a convenient term. Separate parts. So that all of the user interface is in one piece. And all of the business logic, whatever it is your application actually does, is in a separate piece. And they're typically not in the same file. The file that asks you questions like, what is your name? What is your social security number? What is your shoe size? That part is typically gathers the information, does the input validation, and passes it on to a second class. And the second class is the one who says, oh, well, now let me calculate your insurance premium or whatever it is that the thing does. So these things are rarely ever combined. And the idea is, if this was separated out into separate chunks, then when it come time to make a change, like I want to put this on the website, then none of the user interface stuff needs to come across. You can just throw that away because you're starting over with a web version of the application. If, on the other hand, you had all these things all crammed together in one file, then when it came time to port your application from one platform to another, like, I don't know, going from C# to Java, or Java to the web, or, web to Android, those kind of things, then, how their user interface thing changes a lot, but not much else. Anyway, it makes things a heck of a lot easier when you're porting an application from one platform to another. Okay. So here's an example of what they're talking about with a model view controller. So the user basically gets data, and the view is populated with data. And so when the user asks for something or pushes a button, they're talking to the controller. And the controller, then updates the view and, allows the version, the user to see, aha, the answer is 12, that kind of stuff. So it's just kind of a cycle. The data part is typically out there on its own. You don't allow the user to directly talk to the data. So in a 3-tier application, this would have different names. It would be called the presentation layer, which would be this. The data access layer would be this guy. And this guy would be called the business logic layer. So those are the 3 names that we use in other classes talking about the 3-tier application. Okay, so in our world, it's the same thing, just slightly different view of names. Okay, so the model is the data and resources that it takes to, and for example, this is where things are stored. These are where things happen. Okay, the view is, of course, just the user interface. This is where they have visualized version of the data, right? Data has to be shown to the user somehow. And then the controller is where the application, part of the application logic takes place, primarily input validation and those kinds of things. So if you're doing input validation, you're probably doing that in a controller. Cool. All right. So in our world, the MVC is what's considered a passive model. There are other ones. But in our world, the passive model means that the data does not turn right around and try to update anything. In other words, once you send like the guy's first name off to the student class doesn't notify anyone. It doesn't say, oh, but wait, you need to go to the forum and change this. So, right? So it's considered passive because once you get it to the data model doesn't seem the need to update things. Now, in the old days, okay, it was very prevalent, like in a database application, that when something changed at the database, you needed to update your screen. In other words, you have up a customer's piece of data, right? And but somebody else in the organization also has that exact same customer's data up on their screen, and they change the guy's address and hit save. You would expect that your screen that you're seeing would automatically update. That would be an active model where it changes to the database, turn right around and update the view. Okay? Now, that's not normally, I don't want to say that. That's not what I do. How's that? Typically, I don't have the model doing any updating. The model part, the data part is like a dead-end street. If you want to go get something, that's great, but it's not live. It's not going to say, oh, hey, anyone out there has got my customer data? You need to update your stuff. It doesn't do that. Okay. Kind of, sort of makes sense. Okay. So, in the Android world, making this a little bit more closer to home, the view is, the layout, right? That's typically the layout and the widgets and those kind of things, right? The layout form. Okay, cool. The controller is those event handlers, right? Right? So event handler means that's where you're going to be doing your logic. That's where you're going to do your input validation and stuff. And then the model, that's where you're going to be like calculating their pay or whatever it is your thing does, right? So kind of sort of like that. The model part kind of does the business logic and storing of the data. The controller basically says, I'm making sure that everything that the user does is legit. Okay, cool. All right. So this follows what's called a single responsibility principle. And the idea is when you're writing an application, particularly one that's complex, got a lot of moving parts, that you typically don't want to have a class or a file that does multiple things. It just makes sense. Single responsibility principle. That you say, okay, this guy is responsible for validating user input prior to it going to the database. Okay, that's its job. Well, then it ought to do nothing else. It ought not be doing printing or calculating or anything else. Its sole job is to handle input validation. I'll give you a hint. When you're doing input validation, you basically have to have that pretty doggone close to the user because you have to update their screen to tell them that there's something wrong. The model guy can't do that because it can't even see the screen, right? There's no connection between the green thing and the purple blue, whatever color that is. Okay, good. All right. So that's just a philosophical statement. We've actually been doing this already. In our assignments, I've been making you create a separate business logic layer and the data layer, okay, as a separate class, like an employee class or a student class. Those kinds of things. Or, for example, in your term assignment, it's a gazillion employee types, right? There's a standard employee and there's an exempt employee and there's a on and on and on and on and on. Anyway, so I'm forcing you to do those things. I'm forcing you to do the input validation part. And then I'm forcing you to display things on the screen from the data, maybe. I mean, most of the time, displaying things from on the screen is just like in a list, right? I just, like when I hit the list button, like list employee or something, or pay employee or whatever the thing might be. It just goes to the data, pulls it out, and then just displays it as text on the screen, right? So that part's not very impressive, but you see how this kind of sort of works, I hope. Okay. So there's a thing called Android Design Guidelines on page 579. Well, believe it or not, if you go in here and you submit an application to the Android store, they're going to actually go through and check it out. I mean, this sounds a little weird, but here's what they're going to do. They're going to go through and check to see, it's like a test. For example, does your app support a back button navigation and does not make any use of custom on-screen back button prompts? Yes or no? You're going to be graded on your app. Does the app support gesture navigation for going back? The app correctly preserves and restores user or app state. Remember we talked about, device rotation and all those kinds of things? Yeah, and this goes on. I mean, this is a huge list of things. Auto resumes when the application returns, and, background services and stability doesn't crash, or your performance, it goes on and on and on and on. And so these are things that you're going to be graded against. And so it kind of sort of makes sense, if you're going to be one of these developers, that you find out what you're going to be graded against, and you're going to have to do that, because otherwise you submit an application, they're going to come back and say, I'm sorry, dude, we're not going to put that in the store. You don't meet our quality standards. That's what they're talking about, the design guidelines. Okay. So let's talk about real-world applications for just a minute on page 580. Let's say I have an app, and I have it on a phone, on a tablet. I have it for landscape. I have it for portrait mode. It's the same app, but I want it to work on an itty-bitty phone or a monstrously big tablet. I want it to work, if you're holding the phone this way or you're holding the phone that way. I mean, I want it to work, one application to work everywhere, right? Kind of makes sense. And so there's a way you can kind of sort of do that. One of the ways is combining views together, kind of sort of like what I would consider a mashup. That's not what they call it. For example, there's a thing called an image pager and a fragment pager, and we're going to go in a little bit more detail on that in just a minute. But it allows you to stack up different things, and so if I'm holding the device this way, maybe I have 2 columns worth of data, but when I hold it like this, I have 1 column worth of data. So that it's not exactly the same thing when you rotate. Okay, so we're going to do one of those in just a moment. All right, the first thing we're going to do is we're going to do a demo of how to determine some of the critical things I just talked about. Is it a large device? Is it a small device? Is it rotated? Those kinds of things. We're going to find out how you do that. Okay, so here we go. So what I basically need to do is to go in here and tell it that I want to get the display manager. Now this sounds a little weird because up to very recently, all Android devices just had 1 screen. But now that's not necessarily the case. Maybe you have a foldable device where your screen can change size. Or maybe you've got a device where on the front side it's a big device, but on the back there's a small, itty bitty little guy showing, I don't know, the time or something. So yeah, it could have an alternate device, which is a little weird. So I'm going to go here and cheat. I'm just going to paste some stuff I have in the paste buffer. Okay, so I go get a thing called a display manager, and it gets the default display because there could be more than one. And then I need this thing called point, and then I get the size, and then I get the metrics, and then it's going to tell me whether or not the thing is rotated, what its size is, and what the pixel density is. Okay, the rotation is not going to say the words landscape. It's going to say 0 or 1. That's kind of sucks. The size, of course, is going to be in real pixels, and the density is going to be like a relative factor, like 1.5. And I'll explain what that means in just a minute after we get back from this commercial break.